Alright guys, let's start again. So this was what we wanted to do. We wanted to create the view for the game. So we have put this in an activity and we have laid out our buttons. That part is done. Now what we want to do is, we've got the view. That's the view. The controller is the class. I think we added a class when we created the activity in Android Studio. It by default it adds a class. So when we created this game board, if you go and look at the list of your files, you'll see there is a class called game board. This is your controller. So this is in place. What we don't have is the model. How are we going to track what is going on in the game and what changes to make when interaction happens and all of that. So that's our next step, to design the model. Okay, and one of the points of doing all this is, I want to show you one way of attacking such problems. Like if you are given a task, maybe your own, maybe you want to do something on your own. In our case, the task was design an application to play tic-tac-toe and be able to see, to view the history of what happened. So that's why we started with a blank sheet, blank canvas in front of us. We said these are the views it's going to have, and each view is going to behave in this manner. We did the table view, the list view, basically this part last time, and how those things will tie into each other. Today we are doing this. We have designed the view. The model is what we are going to work on, and the controller is the blank class, the stub class that the studio created for us. So how about, what are the things we need to consider? So this is our game board, and at any time, let's say when the game has just started, you've got all 9 squares here, they're blank. Somewhere there is going to be a touch. That will be your first move, right? So, and then the other player will touch somewhere else, and that will be the second move, etc., etc. So the one question we need to ask is, how are we going to track the moves? There are many ways of doing it, I don't know if you have heard this expression. How many of you have seen this? Tim Tody. If you ever program in Perl, there's a language called Perl. It used to be the most popular language when the internet was born for server-side programming. And the people who use that, they know this expression. It stands for, there is more than one way to do it. There is always more than one way to do it. Look at this Android application. Right off the bat, you have 2 choices, Java or Kotlin. You can't say that one is better than the other. There is more than one way, that much is known, but why is one better than the other, you can't really say. If you already have 10,000 lines written in Java, Java is better because you have that much code base. You're not going to rewrite all of that in Kotlin. So there is no, and there are these arguments sometimes you will hear, but there is no one answer. It depends on your situation, what is best for you. If you know Java, Java is best for you. If you don't know something and you know something else which can do the job and you want to get it done quickly. So like in the same way here, if we want to track the moves, there is going to be more than one way to do it. So we are not looking for the best way. We're looking for one way that is reasonable that we will use. So what are the ways you can think of that will tell us? We're talking about the model. So internally, we need to store. So internally, if I look at this property, moves played, it will tell me what were the moves so far, what is in what square. Right? So what would be the appropriate data type? We could go with a 2D array. Yes, we could go with a 2D array. So, 0, 1, 2, 0, 1, 2 like that. 2D array is one possibility. So, and because there are a fixed number of cells, you have one more possibility, which is a one-dimensional array. So like these are our button 1, button 2, button 3, right? So if we write those numbers here, we can go with a one-dimensional array also and keep things simpler. So if we want to iterate over it, we don't have to iterate over two iterators, one in this direction, one in the other. So 1D array. See, right now there are two ways of doing it right here. So we'll choose this. It's a bit simpler. It will let us do the job. So this will tell us what were the moves played. The next question is the game model. So when a touch occurs, the controller will tell the model, okay, a touch has occurred on this square. Let's say I touch this. So the model knows, it's the model's job to know whether an X will appear there or an O. So the controller will ask this question, hey, whose turn is it? What should I display here? So we need to track that. Who is playing next? Right? So we need that. So whose turn? This much information will let us draw, interact with the grid. First touch occurs, the controller will ask, whose turn is it? The answer will come either X or O. And then the controller will tell the view, okay, put an X in this square or an O in this square. And then another touch happens, but every time the controller tells the model that a touch has occurred, we will need to toggle this. This will need to switch internally. So when it's X's turn, X will be played, but this will become O. So the next touch will draw an O. Like that. Now, how do we know when the game is finished? If you are actually playing this, what are the possibilities when a game is finished? Yes, so either when all 9 are full, all 9 have been played, right? So game finished. Let's say we had a Boolean called game finished or whatever we want to call it, something to that effect. So this is either all the elements in this array, 1D array, have a value either X or O. So this has greater or equal to, it cannot be greater than 9 moves, it can be equal. Okay. And the other thing you said is when there is a match, right? So that's one way the game can be finished. The other is there is a match. Somebody has won the game. Do we already know when, under what conditions somebody has won the game in terms of what appears in our array or what appears in this grid? In other words, the third question there is, can we predetermine all possible winning combinations? Right? So, winning combinations. So, what are the winning combinations? All horizontal, all vertical. Yes. And then we go 1, 1, 4, 7, 2, 5, 8, and 3, 6, 9. And the two diagonals, right? So that is 1, 5, 9. And 3, 5, 7. These are all the possible winning combinations. We know this already. So when this question is asked, is the game finished? Our job is to take this array, a one-dimensional array, and go through this list. Check the first, the second, and the third square and see if they have the same thing in it, either X or an O. If it has, if it's an X, X is 1. If it's an O, O has won the game. If it's not, then we just go through this list every time. So whenever the game is finished or somebody has won the game, one of these conditions will be met. And when the game is finished, it is our job to display in the view. Maybe here we can say game over, X1, Y1, O1, whatever it is. And after that, we should stop accepting more touches. Nothing should happen, even if there are blank squares. So all these things we need to implement in our model. So this is kind of the thought process you will go through. So, these are the things we talked about. Properties, moves played, who is next, I called it, whose turn, is game over, game finished, and who won the game. Because ultimately, for the controller, it's not enough to know that the game is finished. It needs to know how it finished. Whether somebody won or was it a draw, or what message to display here in the view. So that part. And at some point, once the game is over, it won't accept any more moves. So that is okay. So what we will do now is we'll create a new Kotlin file, which will become our class for this model. And we'll implement these things in there. So all of you by now, you know how to create a new file in Kotlin, in Android Studio. We'll do that, we'll say new. So you can right click here on this folder. This is where we want the file to appear. So you right click and just say new Kotlin file, and it will ask you what is the name. We'll call it game model. And in your case, I want you to use these names. I want you to use your names in your projects. So use your first name, then underscore game model. This part is a bit flexible. You can call it tic-tac-toe game or game model. But use your name. So I will do the same. I'll use my name. Okay. And it's a type file, and say okay. And it is going to add it and a blank class for us, right? We'll declare its, as you're typing, it gives you suggestion, right? Now we've got the basic declaration is there. We need to define these properties and then work on the functions that are going to be required to provide whatever the functionality really. So what are the keywords from our last class? How do we declare properties? What is the keyword? Let or var. Let or var is going to work, but in Swift. Val, yeah. Let's take a look at variable declaration, right? Declaring variables. Var is also an accepted keyword. Okay. Val. It's not let, right? Read only is val. Okay. And var is something that will change. Variable. So we will use, because these will change in our case. We cannot declare them as static or, non-changing values. So that is what it will be. So there are ways you can specify the type explicitly, or you can let the compiler determine it. This part is optional. Okay, so that's one. And how about declaring an array? How do we do that? So some utility functions, right? So here, for example, this is declaring an array with 5 elements, and it is going to initialize it to 0, 1, square of whatever the I is. In our case, we want to do something like this. We want to initialize it as a blank value. And what will be our array type? Each element will be of type, the type of the elements. So in our case, so here this is an array string. See, this is string. We want a string array, right? Because we will be storing either X or O. We won't be storing numbers or. So let's do this. We'll say and we want 9 elements and we want them initialized blank. Actually, it's make sure there is nothing inside. It's just a blank null value or an empty string. And this is how you initialize. We could have just declared an array 9 and then they would be null. That is also acceptable. That will also let you determine whenever we are using an if there is something in that cell, it will let us do that job. But let's say we want to initialize it as an empty string. And then our next is whose turn is it? So right now I'm going to hard code it as X. X is going to start, but we can have this change. We can have the user select who is starting, who's playing X, who's playing O. All of those are, can be options when you start a new game. Right now, let's just say that X will start the game so that it is initialized. What else did we have in our is game over and who won the game? Okay. So let's call who won. Nobody has won the game yet. Okay, let's leave it at this. And now we want to implement a touch, something that the model will do. And the controller will call the model, say, okay, touch on square 5. So we want to implement that function. Let's call it process touch, and it is going to receive an argument. So the number of the square that was touched. This is the function declaration. It is going to process the touch. Now let's say this function is called with an index, whatever the square is. 1, 2, 3, 4, 5, 6, 7, 8, 9. Array indexes go from what to what? If this is an array of 9 elements, 0 to 8 it will go, right? So we will all the time have to make sure that we keep -1, or we could declare an array of 10 and always ignore the first value. So our naming is consistent. I mean, we could go and name button 0, but button 0 doesn't sound as good as button 1. So what we'll do is we'll change this to 10 and we'll always ignore the first element. So now this is known. So what do? It is telling you this square was touched. What are the changes you will make to the model now? Let's say it's the very first move. And you have received the center 5. What will happen to these variables?
We have to put the, for example, if it's the x, we have to put the x at the number 5.
Exactly. And what else should happen?
Whose turn should change to O?
Should change to O. Perfect. So that's what we'll do. We'll say moves played num whose turn, right? Okay, what is the way to compare strings in Kotlin? Double equal? In Java, what is it in Java? Double equal, what does double equal do in Java? If you have two strings. In Java, double equals will compare the reference object. It will not compare the value. In Java, you have to use dot equals. So in Kotlin, find out how do you compare two strings. Either of them will work. Okay, so let's go with double equal, easier to read. And actually, you know what we are doing here is we are doing this x and y everywhere, right? There is a danger if we use literal strings in our comparisons everywhere. What is the danger? And what is a better way of doing this? Something equivalent to that will be there. So we could use enums. You guys know what enums are? Yeah, okay. So we could use that. We could define a class with constants, string constants. That makes it even easier than enums because then we can just dump it wherever we want to print it. So this has the danger is that you can have capital X somewhere, small x somewhere. You can have A, B, C, D, whatever you wanted you could have. And you could have a bug like that and it would be harder to find. So if we declare an inner class, see the way here in your past, there is a data class, right? Past game, and it has these values. In a similar way, we can declare a class of constants, just constants, and use that. Where is my... Yes, in the game board file. I'm going to try just class and say here we are giving constants, right? Constant value what is this problem? Now going at top level or in objects. So let's just go with no, not Y, we have O. So this way, this will give us an access to these objects and we can use these in our comparisons where we want to print these strings. So then there is no danger of, mistyping, case sensitivity is all gone. So what is the equivalent of static? Have you seen this keyword static in Java? So who can tell me what is, if these, let's say if this was a Java class and the keyword static was there, it's not a valid Kotlin keyword, what would it mean in Java? What does the keyword static do?
For like memory management and stuff.
Yes, so that's the thing, that all the objects of that class share that space, and it's a static variable. That's when it is, that's the use. But there is another advantage to static, which is you don't even need to instantiate the class. You don't even need to create an object. You can refer it by just class name dot the member, whether it's a function or whether it's a variable. So you don't even need to instantiate, and that is what we want. We want here, I don't want to have to create an object of this constants class. I just want to be able to say constants.x, constants.y. So that's our functionality we want. So what we want is static objects in Kotlin. We want to find out what is the equivalent of code sample. It's just public static int. I don't know if this is actually accurate. Companion. It becomes a companion object. Okay. So that is what we want. We basically want, that's the one headache you're going to go through in your life, which is people keep inventing new languages. What's wrong with the keyword static? Just retain it. But they have to invent another terminology, companion object, and they will have some justification for it. But the good thing is that, it has become much easier to find the equivalents because of the internet. 10 or 15 years ago, you would have to do a lot more than that. You would have to grab a book and go to some chapter in it and read it. Could not just ask a question. So even this is right now not very clear. Let's say I want to say companion object and just declare the variables. See what happens. Okay. Oh, I created this in game board, right? I should have done this in the game model. I'm going to delete from here and move it to the game model. You even asked me, Shahrukh, I didn't catch it at that time.
That's why.
Yeah. So where is the game model? Okay. Okay. So here we are going to say now, let's see, constants dot over x. Perfect. This makes our life easier. And if whose turn is equal to constants dot x, then we give it another value, which will be, what will be the new value? Dot o. Else so we're toggling this between o and x. What else can this method do for the controller? The controller has, a square has been touched. It will invoke this method of the model process touch. Should this method return something that the controller can use?
Yeah. Which one? If it's X or O.
Yes, it should return this object now. Whatever was played just now, it should return that. So we want to say whether X was played or O was played. Now we have already changed its value, right? So if we return it from here, we are going to be returning the wrong value. Internally, we have updated that X was played, but whose turn has now become O. So we have to store it temporarily in another variable. Make sense? Okay. So let's go ahead and do that.
We have like next turn in the variable.
So we could declare, we could store here. Let's call it playing now equal to whose turn, right? So this is our temporary variable, what we have just played, and we want to return that. In fact, we could use this here instead of whose turn. Doesn't matter. Effect is the same. So how do you tell in Kotlin whether a method is returning something? In Java, you would put the return type. For example, if the function was returning an integer, you will say int, public, int, whatever, private, whatever the type was. In Kotlin, how do you do it? In Swift, have you guys gone up to that point? In Swift, how do you do it? So Kotlin has borrowed the same design principles as Swift. In Swift, you make an arrow like this and you declare the type. In Kotlin, you just say colon and the return type, and then you return that from here. This is now complete implementation of the function that will process a touch. Okay. Where do we call this from and how? All of this. How do we use it? In the game board activity, right? So to be able to use it, what do we need? We need to instantiate the object first. So we instantiate it. We've got an object here. What we are missing right now is what happens when a button is touched. You don't have that function. How do we do that? How do we connect these buttons to a function call? How did we do that in the calculator? On create, you can assign an on-click listener. We did it slightly differently. How did we do that? So, a hint for you. You go to your game board, right? From here, if you want to say what will happen when a button is touched, What attribute do you change? See, common attributes is one called onClick, right? So what we want, we could say go one button at a time, or we could select all 9 buttons and say they will all invoke the same function regardless of what is touched. Okay. So now action is what we are looking for. No, not action, onClick. OnClick, we have to give a name to this function. Let's call it square touched. So this is what the function name it is going to look for. And now we will promptly get an error here, all these red dots. Corresponding method, oh, come on, just disappears. Handler not found. Right. So this error is repeated for each button because we don't have it. We don't have this. And its error message is still in Java. We are working with Kotlin, so they haven't caught up with all of this yet. But anyway, our job is to declare that function in Kotlin. Now in our game board class, we have to add that function, square touched. And it is going to receive as an argument, you can look at the error message again. The class, the wording will change, but the class definition will not, the function definition will not. So if you go back to this and you look at this error, void square touched, and it gets an object of type view. Which view was touched? So that's exactly what we want to. The same type we will create a void, meaning it doesn't return anything, and it receives an object of type view. So now our job is to find out which button was touched. We've got the object here. So it will return this entire view. For example, if this was touched, it will return the view object. What is in that view object that tells us that it's the 5th button? Button ID, exactly. If you examine your game board and look at these buttons, see, it's called button 1, right? What is this button 1? Button 1 is actually its ID. So if we retrieve the ID, we know which button it is. We can remove the word button and we will get 1, 2, 3, 4, 5, or we can have an entire, just like we did for the calculator, we had a switch case. We could do the same, and we could run through all the IDs and just process that. So there are many ways of doing it once again. So how do we retrieve the ID of the button that was touched? So find view by ID will find us a view if given the ID. We want to do the reverse. Given the view, we want to know the ID. Right? We want to do the reverse. So it turns out it's actually really simple. So let's say actually I'm going to this item. No, item, I don't like this keyword. It's not very representative. Let's call it square, because the square has been touched. Square dot, see, as soon as I press dot, it gives me all the options. There's one called ID. Right. So we got its ID. Now here is a fun exercise for you to find out what is the equivalent of switch case in Kotlin. Learn something else. No, because a button is also an object of type view, and view is what has got the ID as its property. If the button had its property, a property, then the view will not be able to access it.
So it's when it's for switch.
When, right? When, okay. So let's say when ID. What do I do next? Is there like a case statement?
Instead of case, it's just the value.
Just the values. Okay. So what are the possible values here? Button 1, button 2. How do we access? See, button 1, is it a string? Is it a what type of object? What is the? So let's say I want to say when it is button 1, do something. How do I say that? Can I write a string button 1? What do I do? Internally, how are the IDs stored? If you were calling find view by ID, what would you type? In XML. That's correct. That's how you would reference it in XML. In Java or in Kotlin, how would you do it? Did we do it last time? We did. We did for the text, to update the text when we were doing the calculator. We retrieved the text view so that we could update it. Right? What is it? What is the construct? Here. Oh, I think this is an empty. I must have given it a different name. Yeah. See, this is exactly what I'm talking about. It came even highlighted. This is how we reference the ID. R.ID. R is the resources object, internal object for storing everything in that XML that is going on with add something dash slash. It comes through R here. So that's how we'll do it. We'll say when this value is what? R.ID. These are all the options. Button 1, button 2, button 3, right? Then what is the syntax? Dash and arrow, like you make an arrow, right? Like this, a pointer. This would be a pointer in C or C++. And this is what it will do. So that's one way of doing it, right? Let's say square index. I want to define a value, declare a value called square index and set it to 0. We don't work with 0, so that will give us the option. And here we just say square index and we'll make. So this is one way of doing it. Like I said, there are many ways of doing it. You could find a way to, instead of using so many statements, I don't know if it exists, if it will give you the button, the ID in string. Does it have a .to string? Okay, it does. So you could retrieve it as a string, replace the text button, and then you've got a number that you can convert to a number and pass that as the argument. You see what I'm saying? There are two ways. So depending upon what you are doing with it, you may have multiple options. In our previous case in the calculator, we got the text that was on the button, and we used that in the switch case. And there it was very useful if the text was a digit, do this. If the text was an operation, do this. If it was an equal to, do this, etc., etc. Over here, we have all these options. So this is one way of doing it, and it is complaining because all the IDs are the same. It needs 1, 2, 3, 4 up to 9. Which one? Yes, you're right. It's a variable, so yes. So both the ways you can do it this way, and this one here now I don't, because I'm doing it this way, I can't say toString. Oops. So this allows us, see, if we had gone the other route where we use the string, you would not have seen what switch case looks like in Kotlin. If we do the id.toString, you replace, let's say you got button 4, button 5, whatever it is the text, you say, okay, replace the word button out of it, you will get a number, you convert it to an integer, and then you pass it along. And you don't get to see what switch case looks like in Kotlin. So that's why I chose this method, so that you will see that another feature of the language. Okay, and now we will call that method. Well, move played. I'm just going to move played, what was written now on the board, and we'll call it game model dot process touch and pass it square index. Okay, so this will tell us what happened. This will do all the things that it needs to do in the model. What do we do with the value we've got now? What is it going to return? What are the possibilities? So this is our process touch function, right? We've called it here, and it is returning something. What are the things it can return? Who just played, right? So the X or O. What do we do with that? Now we've got it with us here. It's stored in this variable. We need to do something with it. Display. Change the text of the button that was just touched, right? So how do we do that? How will we change? Which button was just touched? This one. We have it here. It has been passed as an argument. So we'll just say, now what you said, Hamza, will come into play. Does the object view have text as a property? Can we set text, or do we need to cast it? Does it have a text? Does it look like it? Right? So we need to cast it. Okay, here is another exercise for you. Find out how to cast an object from one type to another in Kotlin. One hint, it's similar to what you do in Swift. So we need to cast this square, which is of type view. We will cast it into a button and then change its text, because the view itself does not have a property text. A view can be, of various types. It does not have a, at the parent level, it does not have the text property.
Is. Is.
Is.
It's like that. Is or has their word.
Is, I'm not sure what exactly is does. It's a check. It's for checking, right? If something is of type, right? Okay. As is going to cast it. So here is what you would have done in Java. Our object is called square, right? In Java, you would have put in parentheses in front. You would have called it, let's say, a button. This is in Java. In Kotlin, what you do is you will say square as, and whatever the type, button. You could assign it to a value, or you could just invoke the method you want on it. And this is identical to Swift, just so you know. In Swift, you say as something, and it will cast it. So we'll say square as button dot. Okay, this will say it is not imported. Just take your cursor there and press Alt Enter, and it will import it, and the warning will go away. And what do we do here? Text, right? Go ahead and run your app and see what happens now. Oh, there is a problem here. You will find out. I have at least in my code. Huh?
You have to take twice. No.
See, my code has a problem. I'm setting the index to 1 all the time. I should set it according to the button index. So this needs to change. I don't know if you have the same problem. Otherwise, regardless of where you touch, the model will think you are touching the first square. You won't discover that this is a problem until it is too late. You have to touch twice.
Sometimes. Not sometimes.
Changes to O. Yes, because we are not checking. Here we should check if the square already has something. If it has, then don't do all this, right? So that's the first thing we can fix. Okay. The problem is that I gave X as the initial value everywhere. So first we get rid of that. Let's do that step first. If you already have an X, when you touch it, it assigns an X, which was already there. And then it will change to an O. So let's start by doing that. Select all these buttons, all 9 buttons, and change their text to nothing. Just delete the value and press enter. That way your board will become empty. That will fix one problem. Try it now. So this is what it looks like now. And you've actually got a game board which can replace paper and pencil already. If you're playing with a friend, you don't need the computer to tell you that the game is over or not. So you reached a point where you can play the game, but the logic is not all there. The game should be more intelligent. Even though the game is over, I can keep touching, which does not make sense. Yes, so if there is already an O, if I touch, it becomes an X. So let's fix that part first. Let's say that if there is already a value, then don't do anything, right? How do we do that? So this happens in the game board. This is where the event is going, right? What can we put here to not do anything? What is the check? What is the condition?
If X is not null, or if it's null only, then add the value.
Yes. So what we'll do here is, again, we'll say this is our, right, the text. Square is button. I'm going to just copy this and say if I can put this as the very first statements of this. So what it is doing is it is checking if the current text length is greater than 0, meaning it has an X or an O, just go back. So now if you play the game and you double tap on it should not change the current value. So this is a useful thing. You can return from anywhere, really. Even though the function is void, you're just returning, meaning, okay, skip the rest. Otherwise, we can also embed it in an if, entire thing in an if block. Does it do what we want it to do? So far, so good? Everybody on board with it so far? Okay. No? No have a problem? You're having error? What is the error? So, yeah, that's strange. It creates a copy, right? Just go to that folder, right click on the file here in the tab and look for this option, show in Explorer or Finder, and then delete that file. That r2.java, delete that. Okay, so for you, Jagir, this is missing. Playing now needs to be initialized. Okay, so now it lets you play the game, but it lets you fill up all the 9 squares. You can keep on playing until all 9 are filled, and then it won't accept any more touches because each square has got something in it. But we want to implement the logic for before that. After a move is played, we want to know, has the game finished already? So that is what we will implement now. So game model is where we will do it. We need to implement a function called isGameFinished. Let's call it that. IsGameFinished. It won't take any arguments and it is going to return a What is the type for Boolean in Boolean? It's a capital B. Does it take bool? No. Okay, so we need this, right? We need to store this internally so that we can iterate over this and see if these conditions are met. Because this is predetermined, we can store it as a constant in our model and then go over each element to see what is happening. So here, this is where we'll use a two-dimensional array. So this is an array itself, but each element is also an array of 3 integers. Okay. So what we need is to initialize the winning combinations 2D array. This is good. We saw what it was doing with arrays to initialize, right? So there is a way we can create a one-dimensional array and then initialize each element to another array to create a 2D array. That's one way of doing it. Let's find out if there is another way of initializing a 2D array. Now it is suggesting just that here. Code sample is that. You declare two arrays and go with that. Okay, that's what we'll do. So no, there is a better way of doing it. Because the values are predetermined, we can just initialize them. We can use this function int array of, right? So this is what we'll do. We'll declare a variable called winning combinations, which is an array which is made up of, look at the syntax here, int arrays, integer arrays. And it is equal to, you can put in all the combinations here. 1, 2, 3. Int array of. This is the theory, but in practice it is not working. Why is it complaining? Required array int array found int array. What is the problem here? Two D array in Kotlin, right?
What they did is create two different arrays and then put it in one array.
Yeah.
So the array even and odd, so these are like completely different single arrays, and what they did.
Yes. What we are missing is this keyword. See, that's exactly what we are doing. We are doing it in line. We are creating these elements in line, but we are not telling that this itself is an array. I have just, this is a hangover from using other languages where round brackets automatically create a list or an array. So we add all the winning combinations like this.
Instead of array, int array, if I only allow this one,
You just say array of.
and remove that array instead of that int array.
So what does it look like now? That's because right now you have only one element. Add another element and see what happens. So understand what happened here. We declared this variable winning combinations, and we declared its type as an array. An array of what? An array of integers. So each element itself is an array of integers. And to initialize it, we are saying it is an array of what? And all the objects will appear here. So everything that we have on the board there, all the 8 possible combinations, should be in this array. So how are we going to use it? Where do we use it? In this function, right? We need to, what do we do with this now? We've got this as an array and this as an array. So if we were to just describe in English, what are we going to do? Compare, okay.
How many indexes are full until
So this here has the moves that are being played. So 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever it may be, the index, what is in each square, right? And this is a fixed list of winning combinations. So our iteration will be over what? Which array? We'll iterate over one of these two arrays. This one. So we'll take its first element and say if 1, 2 and 3 in this, the elements 1, 2 and 3, if they are all X or they are all O, game is finished, stop iterating, get out. If it does not match, go to this. If it does not match, go to this. Keep doing that. And if nothing matches, then you say game continues, game is not finished. Then you return false. If game finished, will return false. Otherwise, it will return true whenever one of these is a match. Okay. So, that is our job. Even before we do that, what is the minimum number of moves required for a game to be finished? 5. At 5, somebody could theoretically win. But less than 5, the game cannot be finished. It's impossible because both players have played only 2 moves. They cannot have a line of 3. So the first thing we could do is if number of moves is less than 5, just go back. So for that, we need to start tracking number of moves. Instead of, iterating over moves played and finding out how many elements are filled, we could just define another variable called number of moves played. Initialize it to 0, and then every time this process touch is called, first thing you do is you increment it by 1. So you declare the variable number of moves played and you add this line as the first line to your process touch. This won't work in Swift. Swift people decided that plus plus is no good. So plus equal to 1 is what you'll have to do. Okay, so here let's do the first thing. We'll say if number of moves played is less than 5, return false. Otherwise, iterate over winning combinations. So the time now is 2:47. We have 3 minutes remaining to our class. So this we will start. How about it? How about you guys give it a shot? Okay, so you guys try it as your homework assignment, and we'll take it from there. And I want to wrap up the class. What was it that I wanted to? Yes, a couple of announcements I wanted to make. The first is that week 7, Monday is family day. So I think the college is closed and there won't be any class. So we'll have week 7, there won't be a class. So next week is week 6, week 7, we were supposed to have a midterm. What I'm going to do instead is I'm going to give you a test in class of 10 marks. And it will be open book. It will cover any of the topics we have seen so far. It's open book, meaning open internet. You can search. You have, full freedom to do whatever you need to do on your own without talking to each other, without emailing or texting some friend who is a hacker and who can do your job in no time. So that will be prohibited, but other than that, you will have time in class. So we'll have a test. It won't be very long. I think we'll keep it to half an hour or so. We'll give you one problem that you will need to solve as a part of that. Okay?
So I have to write code on paper?
No, you will do it. You'll do a project. You'll create an Android Studio project. You will write code inside Studio. In Studio, run the project, and that is what your test is, to create a project and implement whatever functionality I will define. Next week, because the week after that is week 7, there is no class. And because there was supposed to be a midterm, I don't want to anyway. We'll just do it, a part of it. I think we had assigned 20 marks to it. So what we'll do is we'll split it into 2 tests of 10 marks each. So the next class, you will have a test worth 10 points, 10% of your total weightage. Okay, and as usual, I'll post some reading for you that you can read, and I want you to try this. Finish this implementation of this winning combinations, and that way we'll get a little head start. Okay, good. Any questions?